Hello dear students to one of our new math session. Today we'll be talking about the set of rational numbers. Let's remember some sets. The first set is the set of counting numbers, which we call it C, that has all the numbers that we count with, like 1, 2, 3, 4, etc. The set of natural numbers N that starts with 0, so it's 0, 1, 2, 3, 4, and so on. The set of integer numbers, set Z, that has -3, -2, -1, 0, 1, 2, 3, 4, and so on. The integers are whole numbers, no decimals, no fractions. What is a set of rational numbers? The set of rational numbers is the set that contains numbers which can be written as a fraction and it's denoted by Q. Any number that can be written in a form of a over b is considered a rational number. But for sure, when I say a over b, b cannot be equal to 0. Let's go to this exercise. In this exercise, the question is asking us to show which of the following numbers is rational and which is not. By the way, the number that's not rational, we call it irrational number. We said again, the rational numbers are the numbers that can be written in a form of a over b. So in number 1, 1 over 2 is a rational number. Number 2, 20% can be written as 20 over 100, so it is a rational number. Question 3, 2.3 can be written as 23 over 10, so it is a rational number. Question 4, -2 all to the power of 3, which is equal to -8, can be written as -8 over 1. It's also a rational number. In question 5, this mixed number can be easily written as a fraction, so it's also a rational number. 2 to the power of 0 is excellent, it's 1, so it's also a rational number. In question 7, 2 minus 2 over 5, which is 0 over 5, which is 0, which is also a rational number. 3 over 2 minus x, where x is not equal to 2, this is a fraction, so it is a rational number. 3 over 2 minus 2, which is 3 over 0, that's irrational because the denominator cannot be 0. So this is not a rational number, that we call it an irrational number. Question 10, 3 over x minus 4, where x equals 4. So when you replace x by 4, the result in the denominator will be 0, so it's 3 over 0, which is an irrational number. The set of integer is a subset from the set of rational numbers. The rational number a over b is an integer if what? If b is equal to 1 and b is a factor of a. Exercise number 2. Which of the following numbers is an integer? We said again, integer is a whole number, no decimal, no fraction. In number 1, 5 over 2, is it an integer or not? Definitely it's not an integer. Question 2, 15 over 5. What's 15 over 5? 15 over 5 is 3, and 3 is an integer. Question 3, 5 and 2 over 7. This mixed number can be written as a whole number? Definitely no, so it's not an integer. Question 4, it's 0 over 5, which is equal to 0, and 0 is an integer. Exercise number 3, complete each of the following. If 5 over x is a rational number, then x is not equal to what? Again, we said rational numbers are numbers that can be written as a fraction where the denominator cannot be 0. Here, for sure, x cannot be 0. Question 2, if 2 over x plus 3 belongs to q, then x cannot be, yes, as we said that the denominator cannot be 0, so x cannot be -3. So here, x cannot be -3. Question 3, If x minus 6 over x minus 4 belongs to Q, then x cannot be, yes, what makes the denominator equal 0? Yes, excellent, it's 4. So x cannot be 4. Here in question 4, it's different. If x minus 3 over x plus 8 is 0, then x equals what? What makes the fraction equal 0? Yes, excellent, when the numerator is equal to 0. So this fraction is equal to 0 if x minus 3 is equal to 0. So x equals 3. So here in number 4, the answer is 3. Let's go now to the different forms of rational numbers. The fraction form as a over b, like 2 over 3, even the mixed number is considered as the fraction form. The decimal form, fraction which the denominator is 10 or its multiples, like 2.5, 0.7, and so on. The percentage form is a fraction, its denominator is 100, like 23% is considered as 23 over 100, 60% is as 60 over 100. The infinite repeating decimal forms, like the 1/3, like the 2 over 11, that can be written as 0.3 repeating or 0.18 repeating. Exercise number 4, put each of the following as the form a over b. -5, so it's -5 over 1. 0, I can put 0 over any number I want, for example 3. 0.75, it's 75 over 100. -0.01, it's -1 over 100. 5.4, it's 54 divided by 10. 30%, it's 30 divided by 100. 4.5%, it's 45 divided by 1,000, because it was 4.5 over 100, and we cannot have decimals in fractions, so we add 1 0 in the denominator. And then this mixed number, I can write it as a fraction. If I multiply the 8 times the 3, which is 24, and then we add 2, so it's 26 divided by 3. Exercise number 5, choose the correct answer. If 4 over 5 is equal to 20 over x, then what is the value of x? Here in this case, we can do cross multiplication. How do we do cross multiplication? 4 times x equals 5 times 20. So 4 times x is 4x, which is equal to 5 times 20. So 4x is equal to 100. We divide both sides by 4, then x is equal 25. This is one of the options. So the answer for question 1 is choice A. The number a minus 6 over a minus 4 is not a rational number if a is equal to what? It's not a rational number if the denominator is equal to 0. So if a minus 4 as a denominator is equal to 0, then a is equal to 4. So the correct answer for question 2 is choice B. The rational number a over b is an integer if b is a divisor of a. Question 4, how can we write this as a fraction? The 0.57 repeating, it is 57 over 99. And in question 5, absolute value of -8 over 25. We know that the absolute value, it always gets out as a positive number. So for sure, any of the 3 negative choices is not correct. So the right answer is choice D. Question 6, the rational number x over -3 is negative if, for sure, this will be negative if the numerator is positive because the denominator is negative. So the numerator is 0, so 0 must be positive, so x must be greater than 0. Let's now move to the evaluation part. And please, when it comes to the evaluation, pause the video, try to answer the questions yourself, and then play the video again to check your answer. Which of the following numbers can be written as a terminating decimal? Terminating decimal means the decimal that ends and stops, it does not repeat. So in question 1, you will see that the only fraction that has a terminating decimal is choice 2. Then after that, in question 2, the question is asking me to write each of the following in the simplest form. So in the simplest form, we simplify. 15 over 35, we can divide them both by 5. So it will be 3 over 7, and this is the simplest form. Question 2, we can divide them both by 2, by 4. So you choose whatever you want. Let's say it by 2 first. So it's negative 12 over 28. As you can see, that they both now can be divided by 4. So it's negative 3 over 7. Question 3, yes, excellent. They both can be divided by 15. But if you did not get it, let's start by the 5 first. So it's 9 over 12. Then they both can be divided by 3. So it's 3 over 4. The last one, they both can be divided by 2. So it's negative 66 over 44. Both can be divided by 11. So it's negative 6 over 4. Again, they can be divided by 2, so we divide by 2 up and down. The final result is negative 3 over 2. Now, dear students, we came to the end of our session. Thank you very much and wishing you best of luck.